Today, we're just going to kind of be going over some of that same stuff with slope and rate of change, but going over a couple more ways that we can find slope and just, kind of expanding on that whole idea of slope. So slope, we've talked about it. It's that rise over run. Okay, it's also known as the change in y over change in x. And our definition of slope. So slope is the rate of change of a line, also known as the incline / slant of a line. So essentially the slope, it's, what is a slope? Like a sloped mountain, something like that. It's an incline, it's a slant. Okay. Some different types of slopes. So last time you did notes, we talked about two different kinds of slopes. We talked about positive slopes and we talked about negative slopes. So positive slopes increase in value as we go left to right, and negative slopes decrease in value as we go left to right. Now, two other slopes that we didn't talk about yet would be a slope of 0. So a slope of 0 would be a nice flat slope. And actually drawing on the axis probably doesn't make much sense, but a nice, perfectly flat slope. So a slope of 0 is really like not having a slope at all. It's walking across a flat line, okay? Something to think about to kind of help you with them is thinking of a person walking. So like if I had a positive slope means it would be harder to walk up. I would be kind of walking up a slope. A negative slope means I'm walking down. Okay, down for negative if I was going down my slope. A slope of 0, okay, it would be the easiest to walk. So I'd just be walking like I'm on a normal ground. So the nice thing about positive slopes, negative slopes, and 0 slopes, all of them you could walk up, down, or across. An undefined slope is straight up and down in the vertical direction. And so this one, what would happen if I tried to walk up and down on it? Well, my person would probably fall off because I couldn't walk up that. I would fall. So to help you remember what slope is the undefined slope, it's the one where I can't walk up it. It's like a wall. Okay, so those are kind of our different kinds of slopes. Now the other piece that we didn't really talk about last class are the different ways we can use slope to write linear equations. And this is really the next thing we're going to do with Module 2 and with slope, is we're going to actually use it to write and graph linear equations. So we're going to talk about 3 different slope equations. The first one is the most important and the most useful one. It is slope-intercept form. So it is y equals mx plus b. So y, of course, being our y variable, x, of course, being our x variable, then m being slope. So we know all of those things. The new piece is b, which stands for our y-intercept. So we'll talk about this more when we get to graphing, but the y-intercept is where the line actually goes through the y-axis. Okay. The next equation is what we call point-slope form. So point-slope form, y minus y1 is equal to mx minus x1. So once again, we have x and y are our x variable and y variable. M, of course, is our slope. X, our x variable. And then x1 and y1 are that x value and y value from our first point. If we have, a point to work with our equation. So if we had like an x comma y point, y1, of course, going here for y1, and x1 going here. So if we had a point and we had the slope, we would plug it into point slope form. The last form, and we use it for word problems sometimes, but it's not as useful for graphing and using the slope and that sort of thing, but it is standard form. And standard form is ax plus by is equal to c, with x and y still being that x variable and y variable. And a, b, and c all being constant values. So notice this one doesn't involve slope, so we're really not going to worry about it at all for right now. I just want you to see it, so if you see an equation like that, you can be like, oh, Mr. Arbone, that's standard form. Okay. Now, moving on to actually finding slope, of course, the way we talked about the first time is our slope formula. So m is equal to y2 minus y1 over x2 minus x1. And if you prefer to use the slope formula, by all means, use it. I'm going to show you how to use it, but I'm also going to show you our shortcut because I think it helps you, not get tricked as much, right? So the first one we're going to talk about, we did this last time, but finding slope between 2 points. So if I have 2, 8 and I have 4, 7, the first time I'm going to show you how to use it with the slope formula. So with the slope formula, you have to make sure you know with your 2 points, x1, y1, and x2, y2. So first point is the 1s, second point is the 2s. So I'm going to plug it into our equation. So m is equal to 7 minus 8 for y2 minus y1 over 4 minus 2 for x2 minus x1. So that would be equal to negative 1 over 2, which is just equal negative 1/2 for our slope. Okay, so that's using our slope equation. So that's not the way we did it last class, but I did want you to see that the slope equation does still work. The second way, b, I'm going to show our shortcut. So we have 1, 3 and negative 2, 9. So line up the 2 points, 1, 3 and negative 2, 9. So the change between 1 and negative 2 is negative 3. The change between 3 and 9 is 6. We do rise over run, y over x. So 6 over negative 3, we can simplify that to be negative 2 because 3 goes into 6 evenly twice. Okay, so all of that should be kind of a recap from last class. So we've used this phrase a little bit. Slope can also be called rate of change. So sometimes you're going to see it called slope in a problem. Sometimes you're going to see it called rate of change. They mean the same thing. Okay, and we're going to talk about 3 different ways: slope from an equation, slope from a word problem, and slope from a table. So if I have a table is really just like a larger list of x, y points. So I can kind of use that same trick we used with our points. I can find the change in y, so plus 4, and the change in x, plus 2, plus 2. Notice how it's the same. It should be either the same or the same ratio between all the points. So then for my answer, I can do y over x, so 4 over 2, which would be equal to positive 2 for my slope. All right, same thing on my second table. So change between 1 and 2 would be plus 1. Change between 2 and 4 would be plus 2. Okay, so different change in x, so that's a little weird. Change between 10 and 5 would be negative 5. Change between 5 and negative 5 would be negative 10. Okay, so I got 2 different change values, but just to check, as long as they're the same ratio, we're still good. Okay, so change in y over change in x, I'll do the first one. So negative 5 over 1 would be equal to negative 5. Negative 10 over 2 would be equal to still negative 5. So since they're both equal to negative 5, I can definitively say my slope would be equal to negative 5. Okay, so sometimes it's going to be easy. They're going to be the same. Sometimes they'll be different. You just need to make sure to check that it's the same ratio. If you don't, get that same ratio between all of them, then the table is not representing a slope situation, which we'll talk about that more later. Don't worry about it so much for today. Right? The next thing we could run to is a word problem, okay? So as an example, Angel bought a plant that was 4 centimeters tall at Angel's Green Store. After a couple of weeks, she noticed that her plant was growing 1.5 centimeters each day. What is the slope of the situation? Okay, so what I mean by some buzzwords, words to look for, the biggest one that you probably heard a lot in middle school is going to be per. Okay, so something per something. Okay, because that's representing that y per x, or that, we talked about a little bit with our independent dependent, that independent to dependent. Okay, that change in y over change in x. So per, each, every. Hey, these are all some pretty big buzzwords that are going to mean slope. So looking at our problem, Angel bought a plant that was 4 centimeters tall at Angel's Green Store. So the 4 centimeters tall, that's like its starting height, right? It's already 4 centimeters tall when Angel buys it. Okay. After a couple of weeks, she noticed that her plant was growing 1.5 centimeters each day. So if you notice, each, so centimeters each day. So centimeters, if you remember, that's our dependent. Day is our independent. And that each in the middle is representing that rate of change, that change in y over change in x. So what would the slope be? Well, it's that value there in the front, 1.5. So m is equal to 1.5. All right. Last type we're going to look for is finding slope from an equation. Okay, so finding slope from an equation, it depends on the equation you're given, but more than likely, you're going to get one in slope-intercept form. It's the most common. If you don't get it in slope-intercept form, we can change it to slope-intercept form by solving for y. As you can see, both of these equations here are. Okay? But these are both already solved for y. So just as a reminder, going back to our equation, it is y equals mx plus b. So slope is always that number in front of x. It's not the number and x. It's the number in front of x. Slope is a number. None of these other slopes we found have ever had a variable. They're always just numbers. So let's look at our first equation. Y is equal to negative 10x plus 15. So what's the number in front of x? It's not 10, it's negative 10. Okay, so it's this whole number in front of x. So m in this case would be equal to negative 10. Okay, that's nice and easy. The equation's the easiest one. You don't even have to do any math. Okay. Number 2, we have 20 minus 3x is equal to y. So this one's a little wonky because everything's moved around, but we still have our y by itself. We still have a number in front of x. Once again, this one can be tricky because you're like, well, it's backwards. Is it negative? Is it positive? Remember, the sign goes with the number to the right. So it is negative 3. So our slope would be equal to negative 3 still. So that one is a bit tricky, okay, but still not too bad. And then last thing I just want to show y'all is Mr. Slope Guy. He's just a nice little helpful kind of picture to help you remember your slopes. So positive slopes here in his left eye, negative slopes here in his right eye. As you can see, the shape with the positive eye, the shape with the negative eye. The little nose, that stands for an undefined slope because it's vertical. And then there to make up his mouth are 0 slope, because it's that horizontal line. Okay, and that is Slope Notes Day 2.